Question 1. A man has to go 50 m due north, 40 m due east, and 20 m due south to reach a field. A. What distance does he have to walk to reach the field? B. What is his displacement from his house to the field? Solution. A. Let A be the starting point and D be the field, the ending point. The distance that the man has to walk to reach the field is the sum of AB, BC, and CD, which equals 50 m plus 40 m plus 20 m equals 110 m. So, the man must walk 110 m to reach the field. B. The displacement from the man's house to the field is AD. Using the Pythagorean theorem, we find that AD equals square root AE superscript 2 plus ED superscript 2 equals 50 m. From the triangle AED, we can find the angle phi using the tangent function. Tan phi equals DE slash AE equals 30/40 equals 3/4. Therefore, phi equals tan superscript 1, 3/4. This solution correctly calculates the total distance the man walks as well as his displacement, taking into account the directions of his movements. The displacement is less than the total distance because displacement is a vector quantity that only considers the initial and final positions, not the path taken. The angle phi gives the direction of the displacement. Question 2. A particle starts from the origin, goes along the x-axis to the point 20 m, 0, and then returns along the same line to the point minus 20 m, 0. Find the distance and displacement of the particle during the trip. Solution. Let O be the starting point with coordinates O, 0, 0, A, 20, 0, be the point to which the particle first travels, and B, dash 20, 0, be the final point. The distance traveled by the particle is the sum of OA and AB, which equals 20 m plus 40 m equals 60 m. The displacement of the particle is the distance between the final and initial point, which is OB equals 20 m in the negative direction, since the particle ends up 20 m to the left of the origin. This solution correctly calculates the total distance the particle travels as well as its displacement, taking into account the directions of its movements. The displacement is less than the total distance because displacement is a vector quantity that only considers the initial and final positions, not the path taken. Question 3. It is 260 kilometers from Patna to Ranchi by air and 320 kilometers by road. An airplane takes 30 minutes to go from Patna to Ranchi, whereas a deluxe bus takes 8 hours. A. Find the average speed of the plane. B. Find the average speed of the bus. C. Find the average velocity of the plane. D. Find the average velocity of the bus. Solution. Given. Total distance traveled by airplane from Patna to Ranchi equals 260 kilometers. Total time taken by airplane equals 30 minutes equals 0.5 hour. Total distance traveled by deluxe bus equals 320 kilometers. Total time taken by bus equals 8 hours. A. Average speed of the plane equals total distance traveled / total time taken equals 260 kilometers / 0.5 hours equals 520 kilometers per hour. B. Average speed of the bus equals total distance traveled / total time taken equals 320 kilometers / 8 hours equals 40 kilometers per hour. C. Average velocity of the plane equals displacement / time equals 260 kilometers / 0.5 hours equals 520 kilometers per hour. D. Average velocity of bus equals displacement / time equals 260 kilometers / 8 hours equals 32.5 kilometers per hour. This solution correctly calculates the average speed and average velocity for both the plane and the bus. The average speed is the total distance traveled divided by the total time taken, while the average velocity is the displacement, straight line distance from start to end, divided by the total time taken. Note that the average speed and average velocity of the bus are different because the bus does not travel in a straight line from Patna to Ranchi. The path of the bus is longer than the straight line distance. Hence, the average speed is greater than the magnitude of the average velocity. The direction of the average velocity is from Patna to Ranchi. Question 4. When a person leaves his home for sightseeing by his car, the meter reads 12,352 kilometers. When he returns home after 2 hours, the reading is 12,416 kilometers. A. What is the average speed of the car during this period? B. What is the average velocity? Solution. Using formulas. Average speed equals total distance traveled / total time taken. Average velocity equals displacement / time. A. The average speed of the car is calculated as the total distance traveled divided by the total time taken. In this case, the total distance traveled is the final meter reading minus the initial meter reading, which is 12,416 kilometers to 12,352 kilometers equals 64 kilometers. The total time taken is 2 hours. So, the average speed of the car is 64 kilometers / 2 hours equals 32 kilometers per hour. B. The average velocity is calculated as the displacement divided by the total time taken. In this case, since the person returns to his house, the displacement is 0. The final position is the same as the initial position. Therefore, the average velocity is 0 kilometers / 2 hours equals 0 kilometers per hour. The average velocity is 0 because the person ended up at the same place they started, so there was no overall change in position. Question 5. An athlete takes 20s to reach his maximum speed of 180 kilometers per hour. What is the magnitude of his average acceleration? Solution. The initial velocity, u, is 0 because the athlete starts from rest. The final velocity, v, is the maximum speed of 180 kilometers per hour, which needs to be converted to m/s. 1 kilometer per hour equals \frac 518 m/s. So, 180 kilometers per hour equals 180 times \frac 518 m/s equals 50 meters per second. The time at t is 20s. We can use the first equation of motion to find the acceleration, a. V equals u plus at. Rearranging the equation to solve for gives a equals v u/t. Substituting the known values gives a equals 50 meters per second, 0/20s equals 2.5 meters per square second. So, the magnitude of the athlete's average acceleration is 2.5 meters per square second. This is the same result we obtained earlier using the definition of acceleration.